Recording in progress.
Good morning and welcome everyone who have just joined us. Please feel free to ask any questions. If you have any problems or need assistance in joining the breakout rooms, Incubator 4 and Incubator 5 is now starting. Thank you.
I'm
Recording in progress.
Excited, and so many people are attending today. So very, very warmly welcome all of our participants. Okay, and one thing I would like to emphasize in the very beginning, also for smooth operating of the meeting, I would like to request you to use the chat box if you have any question and comments during the presentation. And all this will be covered during the general discussion session. Okay, let's start our session. And the time is 2 hours.
Excuse me, Lisa. I think you just turned off your microphone.
Okay.
There is still no sound coming through.
Can you hear?
No, video is not.
Can you hear?
I'm using two computers right now because right now the microphone of your assistant is on and not yours.
Hello, and everybody can hear the voice?
Still couldn't hear anything.
I did so.
There is no sound coming. You have to please turn on your microphone. All right, now it should be good. Can you try to speak?
No. 这个你把啥提上来？
Lisa, are you still there?
Okay. Hello, I'm Jin Zhang from University of Toyama, Japan, convener of Incubator 5. In the very beginning, I would like to give a very brief introduction about our incubator. Start my screen. Okay, the title of our incubator is Nothing Marginal About Asian Marginal Seas. The aim is as a central point for unveiling marine environment and productivity changes in a changing climate. We all know that the Asian Marginal Sea is a very important region for human society due to the region's productivity, fishery resource, and large population on the surrounding land. There is no doubt that the changing climate, together with the human economic activity, has wrought significant changes in the hydrological and biogeochemical cycles, affecting the ocean structure and marine ecosystems in the Asian Marginal Seas, and ultimately impacting productivity and fisheries. This incubator will present the latest advance on the science of the Asian Marginal Seas, review the significant environmental changes, and demonstrate the valuable science solutions to serve society needs, in particular for fisheries and nutrient management. This April, a program for international cooperative studies to exchange information and ideas on the Asian Marginal Seas has been approved in the WESTPAC. Co-PIs are Song Xiong and myself, Jin Zhang. Based on the concept of this program, the agenda today of this incubator session consists of 3 parts. Topics, content in program, and communication with fishery, climate, and the social sciences, and the general discussion. Prior to explaining today's agenda, let me briefly go through the Asian Marginal Sea program. This program mainly concerns the marginal seas in East Asia, such as the Sea of Okhotsk, and MSJKR, which means the marginal sea surrounding by Japan, Korea, and Russia, East China Sea, and the Gulf of Thailand. And it is a sense of 2 projects. The project 1 focuses on the nutrient footprint, which results in quantified understanding of a food chain in the ocean. Understanding of the food chain with the nutrient circulation evaluated by physical biogeochemical ocean sciences can contribute to evaluation of fishery resources in the coming stage of global warming. Then project 2 is focusing on the long-term variations in the structure and the circulation of the Pacific Asian Marginal Seas, which is important for the proved detection and better prediction of the oceanic changes in this region due to global warming and climate change. The above 2 projects are supported by these 7 tools, including an arrangement of cooperative cruises and sharing monitoring data and new technology, communication with social science, and exchange student early career scientists. And this tool will be operated independently or simultaneous as a small working group as well. Expected output from this program are as follows. And recommend the means of sustainable Asian marginal seas, enhance communication between the natural scientists and the social scientists. Moreover, new technology, data quality control, data sharing, and an international interdisciplinary interaction are also expected. Outcome of these programs are projected on the ocean decade outcomes, where clean, healthy, and resilient ocean, and the prediction and authoritative ocean, accessible ocean, and inspiring and engaging ocean can be expected. This incubator plan to enhance particularly the activity of the program and expand the exchanges of ideas outside of the program, especially the fisheries and the nutrient management. In the first part of this program, topics related to the behavior of the nutrient in the East China Sea, the MSJKR and the Gulf of Thailand, and the Sea of Okhotsk, and the long-term variation in the East China Sea and the MSJKR will be introduced. Then 2.2 and how the application of satellite remote sensing and the numerical model serve for the program also will be introduced. In the second part, communication with the fishery, climate, and the social sciences from outside of the program will be introduced. Well, examples for the relationship of physical, biogeochemical, ocean sciences to fishery and social science, and international law related to the UN Ocean Decade will be given. These examples illustrate how the outputs of our Asian Marginal Sea program can contribute to the specific stakeholders and the society is in general. So that's all. Thank you very much for your attention. If you have any comments and questions during the presentation, please use the chat box. And this will be covered during the general discussion.
Okay, let's just move to part 1.
Hi, my name is Kyung Kim at Seoul National University. Sorry that I am not able to participate in this meeting as I am now far away from the city. Thank you very much for providing me this opportunity to talk about the sources, fluxes, and the long-term variations of nutrients in the East China Sea and the MSJKR. The Northwestern Pacific Ocean undergoes considerable changes in water stratification and in receiving nutrients from the continent. In particular, there are large input of excess nitrogen from the land to the ocean through the atmosphere as shown here. So in this study, we try to examine the role of other sources such as cross-self fluxes in this region. Our field observations were conducted mainly through Korea East program. Here we are looking at physical and biogeochemical changes in this interconnected system altogether. The field observations were conducted every year in this region. Today, I'm going to introduce one published result about cross-self fluxes and one ongoing research for the long-term change in nutrient concentration in this region. The sampling for the cross-self fluxes were performed in winter since the water masses is vertically well mixed and there is minimum effect of precipitation and the river discharge in this region. The concentration of DIN, DIP, and the radium-228 show the higher concentrations toward the Yellow Sea in this season. As is expected, nutrient concentrations show the vertically well-mixed features, and the nutrient concentration also showed good correlations against the radium-228. It is well known that radium-228 is predominantly affected by water ages in this region. In addition, radium fluxes from the Gulf to the Pacific Ocean has been already well established. So using this equation, we estimate cross-self fluxes of nutrient in this sea. The result shows that cross-self fluxes of nitrogen from the northwestern Pacific Ocean is about half of the entire atmospheric input. And it is even the majority source of external phosphorus to the Pacific Ocean. We believe that this self-source include all natural and anthropogenic sources from river, groundwater, and some from the atmosphere. These also include biogeochemical alterations in the Gulf region. Now I introduce about the long-term change in nutrient concentration. Nutrient data have been compiled, and the data are from the EAST program, NIFS, and JMA from 1980 to the present. The study region cover these areas. We went through some data quality examination. The eastern part of MSK, JKR, and the Crossio region, the data shows no clear change in DIN in the upper 10 meter during the last 40 years. However, there is a clear decrease of DIP in the upper 20-meter layer. This trend seems to be associated with the water stratification, but we are carefully looking at the reasons for the systematic changes of water and the DIP in this region. However, in the western part of MSKJR and the East China Sea showed clear increases of DIN and the DIP during 2000 to 2010. Now we are trying to determine the controlling factors for such changes, such as anthropogenic input changes or PDO changes. I may have opportunity to talk more about these findings in the near future. The overall outcomes from this project may include this aspect. Through this long-term observation program in this marginal water system, we will be able to determine impact and the responses of climate change as well as human activities. With respect to the evolution of nutrient concentration, ecosystem changes, deoxygenation, acidification, and carbon cycles more clearly and earlier than the global ocean. Professor Seung-Yeon Nam may receive some questions and provide the answer if possible instead of me. Thank you very much.
Hi.
Okay, just move next one. Gulf of Thailand, will be presented by Anupul.
Hi everyone, my name is Anukul Buranapatiprak from Department of Aquatic Science, Faculties of Science, Burapha University. Today I would like to present about eutrophication in the Upper Gulf of Thailand. What we know and do not know about nutrient loads into this region. The Upper Gulf of Thailand is a semi-enclosed water body, a very shallow one with average depth of 15 to 20 meters. And most rivers in Thailand, including Javaya, the largest one that runs through Bangkok, the capital city of Thailand, emptying fresh water in here. So it looks like an estuary. The discharge of the Javaya River vary with seasons. We can see the lowest discharge occur in April, about 400 cubic meter per second, and the highest peak occur in October of about 1,400 cubic meter per second. The highest peaks can reach up to or over 4,000 cubic meter per second during high flooding years, usually in La Nina year. We face the problem of phytoplankton bloom, very strong, causing by green noctiluca. The water tend to dark green like this. It deteriorates water quality and results in mortality of culture shellfishes and marine life due to the development of hypoxia in the water column. This one shows you that the incidents occur in the northeast of the Upper Gulf of Thailand because of monsoonal wind and current that move to that way. The hypoxia also occur in the west of Upper Gulf of Thailand as well, when the monsoon change the direction from southwest to the northeast, and discharge water move to the west like this. So it can generate high DO near the surface because of phytoplankton bloom and hypoxia in near bottom water due to decompositions where the water stratifications intense around here. Hypoxia developed in the west of Upper Gulf of Thailand, sometimes so huge, so it can cause culture and natural shellfish mortalities. We have conducted field surveys in the Javaya River to investigate water qualities in the Javaya River and in the north of the area. We can see water quality in the north is quite good. DO is in normal, but when the river runs through Bangkok, the DO drop abruptly below 2 milligram per liters. Also, BOD is very high when it runs through Bangkok as well. The results from the same survey also reveal that the contribution from DON is large compared with DAN. We can see clearly from the graph here that DON is very high, over 160 micromolar. But in case of DAN, the concentration is around 20 to 30 micromolar, and the portions between DON and DAN is so high. We can see this more than half mostly. Nutrient loads from the Javaya River were measured in wet and dry seasons in 2020 and 2021 and found that nitrogen loads were much larger than phosphorus load. And BOD load was high in wet season. This direct organic load contributes to hypoxic water development during that time. We also measure nutrient loads from the Bambakung River, which is located in the east of the Javaya River in wet and dry seasons during 2016 and 2017. Even the organic portion in the Bambakung River mouth is not as large as in the Javaya River, but it accounts for 1/3 of the total nutrients concentrations. So it plays an important role as well. NP-mole ratio suggests that the IP is limited in wet season and DN is limited in dry season. Vary with river discharge. DAN and DON loads were high in wet season, also DAP, but DOP was not so high throughout the years. Even just the DON load is high, it can reflect the importance of organic portions on eutrophication and hypoxic water development. From the results of our studies, we can conclude that not only red tide, but also direct organic nutrient loads from the rivers play important roles to eutrophication and the development of hypoxia in the upper Gulf of Thailand. And the measurement of nutrients in organic paths is required and important. To understand clearly in eutrophication mechanism, we need long-term monitoring. The estimation of nutrients from surface runoff, groundwater discharge, and precipitations are also required. The problems become more intense in the future due to climate change. Hypoxia will be more severe due to stronger stratification from rising temperature and greater river discharge. That's all I would like to present today. Thank you very much.
Okay, thank you. Next, will provided by from Russia and the Sea of Okhotsk.
Good afternoon. My name is Vyacheslav Labanov. I will talk about the results of our studies in the Okhotsk Sea associated with post-eutrophication of the Academy Bay by dead salmon. The leader of this research is Dr. Pavel Tichenko, who is unfortunately unable to present these days, so I will talk on behalf of him. Academy Bay is located in the northwestern part of the Okhotsk Sea. This is very wild, a remote area, not many settlements, no industry. But this area is famous for many whales that comes to this area in the end of summer. So the bowhead whales every year observed in many numbers. There are many tourists also comes who observe these whales. But the question is why the whales concentrated in this area? What process provides enough food for the whales? To answer these questions, we organized ship expeditions in this area. First one was in July 2016, and second one was in September 2020. We did CTD observation with additional sensors, measured salinity, oxygen, nutrients, and the pH, total alkalinity in the cruise. and took samples for chlorophyll A, the total phosphorus, nitrogen, and feed and zooplankton to analyze in the laboratories. And next slide, I will show you the results obtained for July and for September. And we will compare the different situations. July is the beginning of summer. And on this slide, you can see that water was still cold. This upper panel shows the distribution of the properties and the surface, and lower panel shows distribution at the bottom. And in July at the bottom, water was around 0, but at the surface it was a little bit hot, a little bit warm. So this water was stratified. But in September, water was warm and water was well mixed because this is area of very intensive tidal mixing. If you look to other parameters like oxygen saturation, this is AOU actually. So we can see that in July, water was super saturated, but in September, it was undersaturated, especially in bottom area. And all other parameters also show us very big difference between early summer, July, and end of summer, September. If you look to PCO2, we see very low concentration, low content in July, and very high content, especially in the bottom area. Same for nutrients, and here is inorganic phosphorus, for example, very high concentration in bottom layer in September. The same for silica, even 10 times more than in July. Total nitrogen slightly higher in September. Total phosphorus also we have a higher concentration, but extremely high, located close to the river mouth in the southern part of Academy Bay. Here's a chlorophyll A. You can see the higher concentration in September again, then in compare with July. And then we made assessment of eutrophic status of the bay using criteria developed by NOPAP. Here's the criteria which correspond to low level high level of NOPAP. And in our case, in July, we see that our area may be considered oligotrophic basin, very low values of everything. But in September, especially for phosphorus, silica, and chlorophyll, and low transparency by Secchi disk, this area may be considered as highly eutrophic basin. But why it is so? What is the reason of nutrients? We checked 2 rivers which enter the bay, but the rivers are quite clean. So no anthropogenic stressors, because as I said, no industry, no settlements, and rivers are very short. And our hypothesis of high eutrophication in the end of summer is associated with salmon. There was the fishes which come to the area, to the rivers, they died, and they transported to the bay. And this is a source of organic matter for further transformation, because various predators, which are many, the birds and other whales and bears, they very fast convert salmon carcasses into nutrients, and that provide very low trophic chain in this area. So our observation in comparison of July situation with September situation show in July the area is very oligotrophic. This is before the salmon come into the area. The concentration of chlorophyll very low. So this ecosystem not enough, couldn't provide enough food for the whales. But in September, situation is absolutely different. So after salmon come to the area, we have very high concentration of chlorophyll, up to 26 microgram per liter. And such ecosystem can provide enough food for the whales. So this is a research group, and Dr. Tishenko is in the middle. Thank you for attention.
Okay, thank you, Slava. And then we will We will move
Hi
to
everyone, I'm Song Nam, professor of Seoul National University, Seoul, Korea. Here I will talk about the status and prospectus of science data and information on the East Asian Marginal Seas. This is one of the talks for the Decade Action Incubator Session 5, the changes in AMS. AMS means Asian Marginal Seas. Through this talk, I'd like to share my vision toward the long and continuous monitoring of the AMS. So here is the brief background. This is the map showing multi-decadal trends in upper 700 meters ocean heat contents from 1993 to 2019. You can see the AMS region here, and especially in the seas around the Korean Peninsula, you can see these red colors, meaning the significant heating. This is one of the most important regions of significant, very fast, rapid global warming. So the environmental conditions in these seas are largely affected by the global warming and climate change. And the seas around the Korean Peninsula consist of shallow shelf seas and deep marginal seas, where multiple physical and chemical processes modulate shaping the environments. To study those processes, we launched the Korea East program. East means East Asian Seas time series. So this is East 2 region. This is the East 1 region. Actually, these studies originally initiated in 1990s, early 1990s, through the program named CRIMS, Circulation Research of the East Asian Marginal Seas. Even though there have been many efforts to collect the hydrographic data starting from 1930s by Japanese, Russian, and Japanese scientists and so on, but international collaboration was initiated in 1990s. And through this international collaboration among the 3 countries, Japan, Russia, and Korea, we could collect modern accurate scientific data from top to very deep parts of the sea by these pioneering scientists. And in 2000s, this CRIMS program is officially as one of the PICES program. PICES, the North Pacific Marine Science Organization. So it is called CRIMS PICES. And East 1, East Asian Seas Time Series program, is also launched to continue those scientific activities. And at that time, the US scientists joined the force through the ONR, Office of Naval Research's funded program named JES, Japan East Sea program. Through the JES programs, US scientists deployed many modern instruments in this sea to collect a great amount of scientific data in this area. Then now, in 2010s, the Korea and Russia continued the international collaboration to collect the data in the western parts of the sea, particularly through the East 1 program. And then now in 2020s, through this WESTPAC AMS program, where the more than 8 countries are already participating, we will continue the international collaboration especially through the UN Decade of Ocean Science programs. Here, I'd like to emphasize 2 different observations, in-situ observations. One is the long observations. Long and continuous time series data have been collected through this one mooring time series station located in the southwestern part of the sea here. It is called EC1, and EC1 have been maintained over 25 years since 1996. And it's now become part of the global network named OceanSight. This is global network of global ocean observing system, the ocean time series observations. And the data collected from 1996 to 2020 are available through the CNOA, the data repository here with this DOI. And the other example is intensive observations. This year and next year, we will collect great amount of observational data in the southwestern part of the sea.
by deploying the modern instruments like gliders, vertical microstructure profilers, bottom mounts, and wire worker, and so on. This is part of the US-Korea joint cruises and joint collaborations and funded by the US ONR, the MJS program. So through this new AMS program and one project named Long-Term Variations in the Structure and Circulation of the Pacific AMS in response to the global warming. We object to set the monitoring points, areas, establishing a data exchange system and common understanding of long-term variations reflecting the impacts of global warming and climate change, and object to provide important information for forecasting future fisheries resources, as well as serious climate disasters and ocean-related hazards. So the complex environmental conditions in this area need to be monitored through the national and international programs. For the national program, we'll continue the Korean National Program, EAST program, with new programs starting from 2023. And under this AMS project, we will coordinate the national cruises, and we will enhance the autonomous data collection, like EC1, for the next 4 years as a first stage. And then we will interpret the data and demonstrate the results and information with the numerical model. And then the second and third stages, we will better communicate with fishery scientists and social scientists and provide some AMS health index and provide solutions and recommendations for the general public. This project will contribute to all the outcomes, all the 7 outcomes of UN Ocean Decade, of course, but I'd like to here emphasize the outcome 6, the inaccessible ocean. To better access the ocean, we need to share the data and information facilitated by this program. So we are currently developing a new science webpage for the AMS, where the basic scientific information, national and international programs, and observational data and metadata information, and also tools for the data processing and analysis will be provided. Thank you very much.
Okay, and let's move to the next long-term variation provided by Tomoharu Senju.
Hello everyone, this is Tomoharu Senju from Kyushu University, Japan. Today I'll talk about long-term variations in the marginal sea surrounded by Japan, Korea, and Russia, MSJKR. The MSJKR is one of the most warming marginal seas in the world. This figure shows the increasing rate of the sea surface temperature around Japan, provided by the Japan Meteorological Agency. Its unit is centigrades per 100 years. The global average of SST increasing rate is 0.56 centigrades per 100 years. Considering this value, the SST in the East Asian seas is increasing at about 2 times of the global rate. Among them, the MSJKR shows the highest warming rate in its central and southern areas, like this. The warming signals can be also found in the deep water in the MSJKR. we investigated recent variations of potential temperature in the 4 representative areas of the sea, that is JW, JE, YB, and TB. Based on the algo float data. The right panel shows the time series of the yearly mean potential temperature at a depth of 600 meters in each area. As shown in the red trend lines, all the areas show a positive trend. This indicates that the deep water in the wide area of the MSJKR is warming. Next, we investigated the ship-based long-term hydrographic data obtained at Station H4 in the northeast of the sea and Station PM5 in the southeast of the sea to see when the warming was started. This is the time series of potential temperature at 600 meters at Station H4 and PM5. To clarify the variation of the trend, we divided the dataset every 15 years and calculated the trends for each period. It is clear that the warming rate has been accelerated since the 1990s at both stations. The dissolved oxygen concentration is also decreasing from the 1990s to both stations. This is the potential temperature profiles at both stations. In the intermediate layer of 400 meters through 1,500 meters. As the warming is progressing in other layers, the temperature profiles throughout the depths are continuously shifting to the warm side year by year. It is known that the deep water in the MSJKR is formed by the deep convection due to surface cooling in winter. In the northwestern area of the sea, around here, therefore, we investigated the winter air temperature at Vladivostok near the deep water formation region. The winter air temperature has been increased, particularly from 1990. This suggests that the warming in the MSJKR is associated with global warming. I have introduced the rapidly changing MSJKR. As you know, there are two measures against climate changes, that is, mitigation and adaptation. For the fisheries in the rapidly changing MSJKR, adaptation strategies are urgently required. To make effective political enforcement based on a long-term management of fishery resources, the information about the long-term variation in the ocean is essential. We would like to contribute to a healthy and resilient ocean and a productive ocean in the UN decades through the oceanographic studies. That's all. Thank you for your attention.
Okay, I mentioned it right at the very beginning. This program project supported by many tools. Now it's time to switch to the first two, satellite remote sensing, and presented by Echo.
Hello everyone, I'm Eko from Jamstack. I'm going to introduce the potential use of remote sensing for coastal water monitoring. Especially here, I will be more focusing on the red tide detection. Here, panels A and B are showing the correlation between the phytoplankton chlorophyll A in the ocean with NINO index and dipole mode index. So these two maps are showing the general response of ocean prime production in the Asian waters to ENSO and the Indian Ocean Dipole. Besides being sensitive to climate change, the Asian waters are greatly affected by the human activities because the waters are surrounded by the countries with high population density. And one of the well-known impact of human activities is the increasing rate of nutrient supply from the land to the ocean. And this increasing rate of nutrient supply can cause eutrophication in the coastal region, which is now can be assessed from the eutrophication map tools recently developed by Maure et al. And now the indication of eutrophication is the increasing chlorophyll A concentration along the coastal region of Asian Marginal Seas within the recent 2 decades. Even though it is not always the increasing rate of nutrient supply from the land to the ocean can cause red tide, and based on the previous works by Wang and Loom, there is tendency of increasing red tide occurrence in the East China Sea and the South China Sea. And very often, this red tide can cause very serious fisheries damages and economic losses. So it is need to have a system that can provide the end users and the stakeholders red tide related information so that they can be used for the early warning. But one of the most challenging aspects if we are trying to map the red tide by using remote sensing observation is the red tide causative species can be very variable in space and time. So here are some examples of the remote sensing application for red tide detection in the 3 different coastal regions. On the left is detection of red tide caused by Noctiluca scintillant in the upper Gulf of Thailand by using the MODIS data and the algorithm proposed by Dwivedi et al. In the middle panel is the case study in the Seto Inland Sea, Japan, where I developed red tide algorithm for detecting the Karinyami Kimotoi bloom. And very recently, Fang et al. Also developed algorithm mainly for detecting red tide caused by Satonella species in the Area K Sea. So this kind of algorithm can be a candidate that can be implemented into the monitoring system, of course, after further verification and validation. And last September, red tide outbreak was also reported in the eastern coast of Hokkaido, Japan. And this red tide also caused very serious fisheries damages and economic loss. And actually, we are under developing a system or website that can provide ocean color related data or information such as chlorophyll A and red tide product in near real time. But currently, the system is only implementing my algorithm, which is algorithm for detecting red tide caused by Karinyami Kimotoi. So the system seems to produce the map of Carina mikimotoi bloom over a large spatial scale as indicated by the red color here. But I think it is too early to decide that the recent red tide in Hokkaido was indeed caused by Carina mikimotoi, because based on the field observation by other research groups, the recent red tide in the Hokkaido was not caused by Carina mikimotoi, but by other species of Carina, which is Carina saliformis. So we are still working on these issues, whether we have to develop new algorithm specifically for detecting red tide caused by the Carina saliformis, or we just need to do some modification on the available algorithm. And the other important aspect in the detection by using remote sensing is the spatial resolution, especially for the small embayment or coastal region like Tokyo Bay, Manila Bay, and Jakarta Bay. As can be seen here, there are many spatial details that can be captured by the satellite imageries with the 250 meters spatial resolution compared to the satellite imageries with the 1 km spatial resolution. So as a summary, the ocean color remote sensing offers a valuable and effective tool for observing the Asian Marginal Sea ecosystem changes over a long-term period, as well as in near real time, which are greatly affected by climate change and human activities. But to be able to effectively utilize remote sensing observation, accurate model or algorithm are required. And specifically for the coastal waters and small embayment, high spatial resolution observations, such as by the Korean GOSI-2 and Japanese SGLI, are required to understand the changes in more detailed spatial features. Thank you.
Okay, next tool is about numeral model. Will be presented by Xinyu Guo.
Hello everyone, I'm Xinyu Guo from Asian University. My title is Hydrodynamic Model, and it is application to environmental and ecosystem issue. So the first question, what is hydrodynamic model? The model actually is solve this equation with some condition. So the condition include wind speed. So you can now actually you can very easily find such product. It calls ocean reanalysis. So for example, from ECMW and also for ENCA, those data center actually provide you the global ocean reanalysis product. Usually its resolution is 1 degree or maybe a little high. And but you know, for those global ocean, maybe it cannot solve you all questions. So usually you need to develop a regional ocean model. So here is an example for cruise ship, and we call this GCOP. And so this one uses some atmospheric flux, and also use some data assimilation technique, and then provide good estimation on the ocean state. So it provide you daily result of ocean current and also temperature and salinity for this 27 years. And use this product, you can do some, solve some physical oceanographic issue. For example, you can diagnose the seasonal and also interannual variation of crucial transport. And also you can diagnose the exchange of crucial and the ship water in the Eastern Sea. And with some addition to its calculation code, you can apply this model to some fisheries issue, like show this paper. And also you can do some simulation for the pollution in the North Pacific Ocean. And also you can solve solve the nutrient and also phytoplankton equations in the North Pacific to estimate the primary production, and also develop it to some carbon issue in this, like in this paper. And this is for some a little high, large regional part. For some base scale, and you can do very similar things with almost the same step. So here I show you two examples for those base scale application. One is for the upper Gulf of Thailand. And several years ago, actually, we developed a hydrodynamic model to understand the plume, river plume movement in this bay. So at that time, we saw those hydrodynamic model to obtain the current. And last year, actually, we applied this model to pollution. The name is SMX. It is a kind of antibiotics that is actually a medicine used for animal. So this medicine can dissolved in the water because of light, actually. So we include this term in our model, and also we include it is advection and diffusion. Then with the river input, it is amount actually shown here. So there are 4 rivers, and we include input, and then we can solve this equation, and then we get this distribution of this, like show here. This colors show the concentration of this SMX, and then we can now it is how much of this SMX decomposes in the bay, like show here. So its annual mean mass is like this number. So with those models, actually, we can answer the equation like what is the concentration, and we can also want to know how long do they stay in the bay, actually. And then we can repeat very similar calculation because the decomposition is controlled by half time, actually. So with different half time and a very different reward input, it is, the mean concentration in the bay. And we also can estimate its flush time, like use this equation. If you have a long, half time, you have a long flush time here. And this is actually the flux. So anyway, so with this estimation, you can answer 2 questions. So another issue is in a bay. So in a bay, so how many? You know there are 2 kinds of nutrients. So one is from river and another from ocean side. So we want to know how much of each nutrient contribute to this primary production for all like phytoplankton biomass in this bay, and also to the nutrient inventory is also one issue. So we apply in actually this research is carried for the Seto Inland Sea. That is very same enclosed bay in Japan, and this bay actually has some very serious environmental issue in 1970s. So at that time there is some law to limit the nutrient input in this bay. So and as a result, you can see it's the reduction of nutrient concentration. And so to understand this change, actually we made a hydrodynamic model shown here, and also we apply NPDZ type model to this. We solve those problems and also separate these 2 kinds of this nutrient. And as a result, we know the river source of DNN has this distribution. So near this river mouth, actually, it is a river source of nutrient there. But for most part of this inland sea, actually, you can find the oceanic nutrient contributes most part of this bay. So the mean volume is like here, 16% of nutrient is come from river and 84% come from ocean. So for biomass, the river nutrient support 20% and oceanic support 80%. So yes, So this is still ongoing actual research. So my conclusion for today's talk is hydrodynamic is a good tool for many marine issues, and maybe people can learn to use this. Anyway, thank you for your attention.
Okay, this is a final talk for the first part, and we're going to have a break. And before the break, I would like to ask everybody to turn on your camera again and to take, because now we have more than 100 participants in this meeting, and let's take a group photo again. Thank you very much for your cooperating. Because the big screen and we need a little bit of time. Please turn on your camera if you can. Please wait. Okay, it take time. Okay, let's take a shot. Big smile, please. Finish?
Yes, finished, but only about half has turned on their camera. The rest, I just got their name.
Okay. Okay. Thank you, everybody, very much. So let's have 5 minutes break, and please come back again. Okay, take a rest. with UNDK. For the first time, we invited the fishery and the social scientists from outside of this program. Okay, the first one is about fishery and will be presented by Atsuko Yamaguchi. Yes, please.
Hello, everyone. My name is Atsuko Yamaguchi from Japan. Today's my talk is about the life history of fishes and their relationship with the environment, but I will mainly focus on life history. Understanding fish life history is essential to predict how populations will grow and respond to fishes. The life history traits are related to each habitat's environment at different life stages such as larva, juvenile, and adult. Today, I will focus on the life history of small commercial species, white croaker. This presentation will show the importance of understanding the properties of the environment concerning the habitat changes at each life stage to conduct oceanographic research that leads to fishes' productivity. The East China Sea is well known for its high productivity and biodiversity. In the marginal areas at the western part of the East China Sea, there is Ariake Bay. This inner bay is characterized by the largest estuary, and it accounts for 41% of the total tidal flood area in Japan. Freshwater input from several large rivers results in relatively low salinity in the inner part of the bay. Also, its estuary serves as a channel for nutrients to pass into productive coastal waters. This unique bay had been called the Sea of Treasures because it functions as nurseries for fish and other organisms and produces abundant resources. However, the total catch of fishes declined significantly after peaking in 1987, and since 1990s, the effect of global warming has also been recognized. Therefore, we have been conducting studies on the life history of fish and their relationship with the environment for the past 20 years. In this presentation, I will introduce our studies on the white croaker as an example. The yearly catch of croakers in Ariake Bay has also been on a significant decline since the 1980s. It was required to elucidate the factors of catch decline. The average fish species composition over 10 years by our trawl surveys showed that white croaker is the most dominant species among the demersal fish assemblages. White croakers distribute are widespread in continuous localities with different environments out of Ariake Bay. Before starting the life history studies on this species in Ariake Bay, we conducted studies on population structures to clarify the range of the target. Our findings suggest 3 populations may exist in the coastal areas of Nagasaki Prefecture, and 2 localities, Ariake Bay and Tachibana Bay, were determined into the same population. The active spawning is observed from May to August. Age at sexual maturity is 1 year. This species is a multiple spawner and had a clear diel spawning periodicity, spawned between 7 and 9 p.m. Reproductive study and the observations of subsequent trawl surveys indicated that white croakers in Tachibana Bay might have migrated to the main spawning ground in Ariake Bay to spawn on the day of new moon of the lunar cycle during summer. We estimated that the main spawning ground of this population formed in the middle part of Ariake Bay at depths up to 60 meters. In fact, when we told on our estimated spawning dates, locations, and times, almost all of the catches in our nets were white croaker. That means our estimates were valid. We also investigated the early life history, distribution, and feeding habit of larvae. Larvae have been collected at the western station but not at the eastern station of the bay. This means that the larva transportation route is at the west side of the bay. There are genetic changes found in the distribution of larvae. They existed in high density in the colder and higher salinity waters of the density front formed on the deeper waters. No larvae were collected in the river mouth, whereas juveniles were abundant. This figure shows the salinity range of the distribution area for white croaker. A clear genetic trend was observed in the salinity range. Large and juveniles tended to extend their distribution area to include a lower salinity range during ontogeny. This fact is related to that as they become juveniles, they enter into the river mouth. Here, I will summarize the transport mechanisms and nursery ground of white croaker eggs and larvae revealed by field oceanographic and biological surveys and DNA analysis. Croakers spawn in the bottom layer at the middle part of the bay. The larvae are passively transported. Water currents in Ariake Bay are significant for larvae to reach from the spawning ground to the nursery ground. Larvae fed preferentially on copepods throughout early development. This species composition of the diet for larvae was species-specific. Genetic changes in distribution and feeding habits were observed. Thus, the food availability, especially for early life stages, critically impacts their survival. Larvae stayed at the water column with a high salinity in the shallow waters. Then, juveniles entered exclusively in the lower reaches of the inflowing rivers. We consider the reproductive strategy is adapted to the unique environment of Ariake Bay with its large tidal range and fast currents. The estuary of the river is an important nursery ground for the white croaker at earlier life stages. In the maximum turbid zone, zooplankton biomass is high. In addition, the high turbidity provides shelter to larvae and juveniles from predators and delivers optimal temperature and salinities. Our studies have revealed the life history and unique reproductive strategies in Ariake Bay population, such as nursery ground being distant from spawning grounds. But we need future studies on the larvae transport mechanism and the environment and food availability in the transport area and nursery ground to understand recruitment success of fish. Thank you very much for your attention.
Okay, the next one is about international law. It will be presented by Yitong Chen.
Good morning, everyone. This is Yitong Chen from Law School, Ocean University of China. So my topic is about international law response to UN Ocean Decade. My research background actually lies into the discipline of international public law, and I have some years research experience of polar law and politics, the law of the sea, the international environmental law, and climate change law. So my contents include three parts. The first one is nexus between UN Ocean Decade and international law. The second part is international law's response to Ocean Decade, and third one is my conclusion. So in 2017, the United Nations General Assembly decided to proclaim the United Nations Decade of Ocean Science for Sustainable Development for the 10-year period beginning on January 1st, 2021 within existing structures and available resources. So actually the existing structures and available resources usually refers to the Intergovernmental Oceanographic Commission and UNESCO, and also UN entities including the United Nations Department on the Law of the Sea and international and regional organizations and associated networks. The UN General Assembly called upon the IOC to prepare an implementation plan for the decade in consultation with member states, specialized agencies, funds, programs, and bodies of the United Nations, as well as other intergovernmental organizations, non-governmental organizations, and relevant stakeholders. The UN General Assembly also requested the IOC provide information on the development of the implementation plan and regularly consult with and report to member states on the UN decade. The UN General Assembly also invited the Secretary General to inform the General Assembly about the implementation of UN decade through its report on oceans and the law of the sea on the basis of information to be provided by the IOC. So usually the international legal regimes includes various conventions and agreements and also associated governing bodies, which includes the international and regional organizations. The ocean decade actually relates to various international legal regimes whose governing work relates or overlaps with each other. So there are numerous international agreements aimed at preserving the ocean, either in the form of treaties or frameworks which have various degrees of being legally binding. The ocean decade will be implemented on a voluntary basis within the legal framework of the United Nations Convention on the Law of the Sea. It represents an opportunity to build scientific capacity and knowledge to contribute to the goals of the 2030 Agenda for Sustainable Development. The implementation plan will provide technical support for a number of international legal documents that are being implemented or under negotiation. The ocean decade will have a direct impact by contributing data, information, knowledge, and increased capacity on the generation and implementation of international law. So what are those international legal regimes relates to ocean decades? It includes but not limited to various conventions and agreements. For example, the United Nations Convention on the Climate Change, including the Paris Agreement, and recently adopted a Glasgow Climate Pact in 2021. And also the Convention on Biological Diversity, including the post-2020 Global Biodiversity Framework, and also includes a Center Framework for Disaster Risk Reduction and a UNESCO Convention on the Protection of the Underwater Cultural Heritage. And another one, right now it is being negotiated, the legally binding instrument on the UNCLOS on the conservation and the sustainable use of marine biological diversity of areas beyond national jurisdiction, usually we call it BBNG. It also includes but not limited to various international and regional organizations, for example, the UNESCO, the IOC, FAO, IHO, the International Maritime Organization, International Seabed Authority, the UNDP, the UNEP, the WHO, WMO, and various regional fisheries management organizations. In history, the development and advancement of marine science and technology always will promote the expansion of the fields of ocean development and conservation. And furtherly, all this will stimulate the emergence of new legal regime with the corresponding scientific and technological achievements as their main content. So what are we doing as the international law's response to Ocean Decade? So the UNCLOS actually worked as the general and comprehensive convention. It provides overall regulatory framework for the conservation and sustainable use of ocean and its resources. And we also have various global instruments under the UN Food and Agriculture organizations to make fisheries sustainable. In the fields of climate change, in the Paris Agreement of 2015 under the UN Framework Convention on Climate Change, it refers to the importance of ensuring the integrity of all ecosystems, including the oceans. And in the recently adopted Glasgow Climate Pact of 2021, in paragraph 60, it invites the relevant work programs and constituted bodies under the UNFCCC to consider how to integrate and strengthen ocean-based action in their existing mandates and work plans, and to report on these activities within the existing reporting process as appropriate. We also have the UN Convention on the Biological Diversity to manage marine and other aquatic ecosystems scientifically, and also the Regional Seas Convention and associated various regional fisheries management organizations to provide regional framework for conservation of the ocean health and its living marine resources. We have the International Maritime Organization to monitor the implementation of a series of international conventions against marine pollutions. So in the field of sea level rise, so actually the International Law Commission already began its work in 2018, which is the codification of international law relating to the sea level rise issue, taking into account state practice, relevant international cases, and customary international law to conquer the challenges from the marine litter and microplastics. So the Global Ocean Governance Agenda for Plastic Pollution has already been underway since the United Nations Environment Assembly established the ad hoc open-ended expert group on marine litter and microplastics. But I also have to say that we still have some work that haven't seen too much work from the international law's response, that is the submarine heat waves and ocean acidification and its multiple consequences. So my conclusion actually is a calling for our natural scientists and social scientists. We still have to think about, first, the response from the existing international legal regimes and involving international law to the fast advancement of ocean science and technology. We also have to think about the influence of outputs from ocean science to international law and especially the law of the sea. And the international law confirms national and regional practice, which accepted as general international rule, which means the coastal states of the Asian Marginal Seas could absolutely take the lead by frequent national and regional practice, including international cooperation, and thereby shape the involvement of international law as regional models and leaders. So this is my presentation. Thank you.
Okay, all this were our presented talk video, and now it's time and switch to the general discussion. And the discussion session is leading by Song Hyun and myself. Let me stop share the screen. Let me see. And the discussion session, there were 3 items, and we have to discuss. And this is what I pick up from the session. And the first part is briefly summary of each talk, address the questions and comments provided the chat box. And the second part is what the possible actions of the Asian Marginal Sea program to contribute to the ocean decay. Final one is if you have any issue regarding to our program or recommendation and can improve the activities. And the first part, beyond the subsection 1, and regarding to the project 1, and it was the nutrient footprints. And there were 3 talks, and Gilbon talk about sources, transportation, long-term variation of nutrients in the Asian Marginal Seas, and suggested necessary of long-term variation program because its changes appear more clearly earlier in the Marginal Sea than in the open ocean. Anaku talked about nutrient loads from a river in the upper Gulf of Thailand, which influence the formation of hypoxic water. Global warming would enhance the influence of the loads to the coastal environment through higher temperature, strong stratification, and large discharge. The third one was presented by Slava Lobanov. Introduced an example of eutrophication in the coastal region of the Sea of Okhotsk, and discussed the nutrient sources. The transport of nutrients is argued consider the highest level of food chain. There is a question to Anaku. So Anaku, please, you just pick up the question and answer here.
Actually, I have answered through the chat, but it's okay. We have done monitoring, like mooring observation in the northeastern part where the strong hypoxia occur. Yes, and we got the data, but unfortunately, we don't have phytoplankton data. We just have water qualities, DO, salinity, temperature, just that for 1 year continuously. Just that. Thank you.
Okay. Thank you very much. Then switch to the topics, project 2, focusing on the long-term variation. First talk provided by Song Hyung Nam introduced historical activities of international cooperative studies, current activities for long-term observation in the East China Sea and MSJKR, then future plans related to Asian Marginal Sea program were explained, showing the roadmap. And then Tom Senju talked about long-term variation of MSJKR and showed clearly increased seawater temperature and a decrease in dissolved oxygen, including possible processes. And the contribution to the UN ocean decay by long-term variation of MSJKR was suggested as well. I think there is no question to this 2 talks in the chat box. We can come back again and only finish every talks. Then for the 2 tools, the first satellite remote sensing was provided by ECO-7 and focusing on coastal water monitoring. So the satellite remote sensing is a very useful, powerful tool to catch the larger context with a high resolution in coastal areas. Even for biological factors, remote sensing would provide useful information. On the other hand, ECO suggested that of a more effective utilization of remote sensing observations, accurate models, and algorithms which are usually located locally were required. And then Xin Yubo's talk focusing on hydrodynamic numerical models used in marginal seas and their application to ecosystem in coastal region. For example, the environmental issue in the quote provided by Anapro may be properly explained with numerical models. So the question I think for this talk, especially for satellite slots, the slide does not move. Okay, here. I think during the presentation and the a lot of questions focus on the remote sensing one, and Echo actually answered in the text chat box already. But I think this kind of information quite important. Would you please just pick up a question and explain or further information provided to everybody again?
Yeah, okay, thank you.
Appreciate.
Can you hear me?
Yeah, very well.
Yeah, okay. So, there are some questions, especially from Professor Lim, that the problem with the remote sensing application, especially from the optical sensor, is the cloud cover. So we cannot escape from this problem. But one thing we can improve to improve the spatial coverage is by using operating multiple sensor, not only a single sensor. So that is one thing that I have already answered in the chat.
Mm-hmm.
And also about the species of the bloom. I think there is also comment on the species in the Hokkaido that is recently happened in the Hokkaido, which is caused by the Carenia siliformis actually. But the system I'm developing is retuning the bloom by the Carenia mikimotoi, because the algorithm is based on the Carenia mikimotoi. So it's maybe we have to work in the more further validation and calibration. So whether we have to develop new algorithm for that species or just modifying the available algorithm. And also, I think that is what I've had a question from the chat, I think.
Okay, thank you very much. And there is the very final one, species of red tide in the Gulf of Thailand and the Fujian province, China. I actually did not catch up the meaning of this.
Oh, yeah, I think this comment from Anukul, I think. So he said that the phytoplankton species that cause red tide in Gulf of Thailand changed from Noctiluca to Carenia, right?
Not now, but there is a trend.
There's a trend for
that we found more blooming of Carenia. Yes.
Yeah, actually, there are some algorithm available for detecting Carenia, for detecting Noctiluca. So we can actually, that is what we have to work together. Actually, we have to test the algorithm based on your in situ data. Because last time I think I received your in situ data, right? Noctiluca bloom.
Yep.
Yeah, so we can work together for testing and for the validating the algorithm.
Sure. Thank you.
Yeah.
Okay, thank you. Thank you very much. And then I mentioned it was our first trial to try to commit with social scientists from out of the program. And there were the two talks, the first from fishery side, and Asuko Yamaguchi, actually she could not make today. And actually there is no question in the text box, chat box. I'm going to pick up question again later. So she presented a live history of fishery fishes and obtained from a large amount of field study in the coast region. And it was shown that the life history is strongly related to marine environment, particularly during the period from spawning to Germany. And this comment, actually, I guess this comment is from Professor Matsuno. Matsuno Sensei, do you have anything about these comments and have to say something additional?
Hi, I think the life cycle or life history of fishes would strongly depend on species and region. While I'm not an expert of the fishes, it would take a long time to understand the life history of the specified fish through field studies. It may be difficult to collaborate simultaneously. However, collaboration with scientists who study the life history of fishes, particularly dominant fishes in the region, should be one way to understand the relationship between environment and fishery resources. We need something like a bridge to connect the marine environment and fishery resources. This slide shows the relationship between the marine environment and the fishery resources. It is usually we say that the marine environment would be related to fishery resources. However, there is a big gap between the two fields, and because the various processes between them are treated as a black box. If we can collaborate with scientists who study life history of fishes, quantitative evaluation of marine environment to fishery resources could be achieved, I think.
Okay, thank you. So just let's move on. And then the second example is focusing on the law, international law. So there is no question at this moment. And so the first part about what are the possible actions for the AMS program to contribute to the ocean decay. So in this session, we raised two examples related to their contribution to societies outside of ocean sciences. And what kind of other contribution to the ocean decay can be expected? And for this subsession, we have a co-chair, Song Hyung, and I would like to open to the floor. We have 10 minutes about this one. So you just please ask question or raise your hand. Song Hyung, do you have anything to add?
Oh, no.
Okay. Anybody interested have question?
Okay, I had better raise one issue.
Okay, go ahead, please.
Okay, from Professor Kyubom Kim's talk and my talk and Professor Tomhara Senju's talk, the long-term monitoring, long-term continuous monitoring were emphasized, right? So, and there was good discussion on the environmental issue in the Gulf of Thailand. So one of my question is there any long-term time series station in the Gulf of Thailand?
Oh,
Anaku.
yes. I don't think there is long-term mooring station in there. Yeah, our scientists need to think about that, and we want to have it badly, but it's very, very expensive to invest like a long-term mooring station in there, as you know. But we will try. Yeah, sorry for that.
Okay, I see. Because one of the comments in the chat was that these events, sometimes subsurface events, could not be detected using the remote sensing technology, and also remote sensing technology requires some algorithm. I mean, developing the algorithm to correct the atmospheric effect and so on. So we need in situ observation for a long time. So that long-term monitoring should be emphasized to better provide some solution for society in the future through this UN Decade program, I think. So.
More question from floor? No more question? Okay. So then we move to the next question. Yes,
okay,
go ahead. Is any hand raised?
You raise the hand, please.
Okay.
Please go ahead, Wenxi.
Yeah, thank you very much. First of all, I would really thank the moderator, Professor Jing and Nam, and also the whole organizing team, and also the speakers for your wonderful talk for provide today. Second, I will say because with very hard work, I think has been taken over last year. I think this marginal seas, or we call it team, or call it task force, indeed, move a very step forward in, thinking more, translating science to serve the society. So very glad. I think it's a great pleasure for us to say the two social society issues have been identified with a strong determination of the scientific group, right, to contribute to the societal use. The third point I say, the Asian Marginal Sea, as we say, nothing marginal about Asian Marginal Sea. That means so many things, interaction between human activity and also natural process. So I think the Asian Marginal Seas, this program provide a very good enabling mechanism for the next 10 years to get the scientific group bigger, to engage more multidisciplinary team, and also to engage more stakeholder, and also finally to generate more science to serve the more societal needs. I think this is very important. The Asian Marginal Sea provide a very continuous mechanism for the people working and also to address the issue in the Asian Marginal Sea. So I think this is the biggest significance of this group and of the incubator today. So last but not least, I have to say, because this is a difficult situation for us, we have to take this kind of working modality. As I say, nobody really enjoy this kind of remote modality, working modality. So I think as soon as the pandemic ends, we will resume our more interactive, discussion, and also with this mechanism, to build the team stronger, to build the network stronger, and also to build science, stronger in order to serve their different societal needs. So I think the engagement today actually is a kind of part of our success. So let's move on from today's success and also plan for the future. Thank you very much, Jing, and also Lam.
Oh, thank you very much, Wenxi. actually our final session, the final part of this session is a summary. It sounds like I have nothing to say after you give a great summary of our program. And okay, just let us move to the summary. Share the screen. This is actually some of the message and from what I learned from this afternoon morning. And we just, because this program is started and the very simple outline of this program beyond the WESTPAC was introduced. And we try to enhance the communication with outside of the program and actually 2 topics we provide and actually we learn from those talks. I think those things is the most important but most difficult for us. The far goal, the final one, the far goal is outcomes expected by ocean decay. This one is very, very difficult. And so we just start to learn to how to figure all these things out, and especially relationship between the environmental fishery, climate, and social science, and make more easier to connect to stakeholders and policymakers. I think we still have 5 minutes. Song-hyun, anything you can help from this summary session?
No, it's good summary.
It's not very good. All right, and still have 4 minutes. And actually, I apologize in the very beginning because of that technical problem, and we missed 6 to 7 minutes, but we still can, finish in time. I quite a strong encouragement from floor or from our member and any question, comments, but it's very much welcome.
Slava raised the hand.
Please, Slava, you're welcome. Go ahead.
Okay, thank you, Jean and Hyun. And I think we're missing one point is a communication with the other organizations and communication with other projects which are active in this area. For example, one of the projects is CREAMS Advisory Panel for CREAMS, which are under Pisces, and many people here are also members of CREAMS. And also the other projects like observational projects and NEAGOOS and SEAGOOS, which is trying to maintain a long-term series of observations. And environmental issue, there is a NOPAP. It's covered northern part of the area, but probably there are some similar organizational program in the southern part of the area. So I think we should develop this closer communication, even operational exchange of the plans and activities with these programs to understand who is doing what and to emphasize our activity to make a real collaboration. I think this is also important, communication with other organizations. Thank you.
Thank you very much, Slava, for your recommendation. Actually, yes, exactly. Intergovernmental and non-intergovernmental actually quite provide different platform, but we need this kind of communication not only in scientific party and try to enhance this kind of a communication and also out of the program. Okay, the time is almost there, and no more question or recommendation. Gil, do you like to give some, because we run quite a similar program, do you have any recommendation or encourage words to us? Gil Jensen Toh? Maybe you're not. Maybe, okay, maybe you're not at this moment. Okay, yeah, maybe. Okay, if so,
Hello, this is Ken.
Ken, please, I missed you. Please go ahead.
No, it's okay.
I'm waiting for you, actually.
Thank you very much for sharing my, time for me. Just my comment is that maybe in this kind of incubator, we may need to continue in future to have a better dialogue with stakeholders. And maybe your project is a kind of brother project of my CSK2 project.
Right.
And as you are feeling, I'm also feeling to search or approach to the appropriate stakeholders. So maybe we may just to echo to the Slaya's comment, we may also need to consider to collaborate to have a good dialogue with stakeholders together in future. Yeah, that's my comment. Thank you very much.
Yeah, many thanks for your recommendation. Yeah, we should actually, I know you're very busy and we should strengthen the communication between CSK and our program. All right, and I would like to close this program. I enjoyed the program today very much and learned a lot. Actually, I really pleased with our progress of our program, even we just started a few months. Of course, we have a previous activity and communication. And during today's program, and some problem discovered, and we have to well discuss, and this problem will be solved within and without our program member. Like some people mentioned, Ken and the Slower, and we have to strengthen communication between the scientific party, other program, and also the stakeholders. Well, that's all from me. And Song-hyun, any words? No? No? Okay. All right. So finally, I would like to thank all presenters and all participants again for your attending this meeting. Thank you very much. And please take care and keep active even during this very difficult situation. Hope we can see you sometimes in near future, face to face.
Thank you.
Okay, bye-bye. Thank you.
Thank you, team.
Thank you.
The opening are going to start in 30 minutes.
Right.
Okay.
Okay, thank you.
You can watch from Zoom webinar and also YouTube, Facebook.
Oh,
okay.
Great. Okay.
See you soon.
See you soon. Okay, bye-bye, everybody.
Thank you,
Take care.
Jane. Thank you.
Thank you.
Thank you very much.
Is Guy still there? Okay, if no, I will send you email. I'd like to thank you very much for your supporting. Okay, bye.